So for G, change your decimal part to a fraction. Can you do that first? That would be 8 on what? Anyone know? What do you think? 0.00. Sorry?
1,000.
Yeah, 1,000. 8 on 1,000 is 0.008. We can check that because we can say 10, 100, 1,000. Okay, so 8 on 1,000. And then you've got minus 2/3. Now I'll show you a trick here. I can show why it happens, but if you've got 2 on 3 to minus 2, okay, if we do that the long way, that would be 2 minus 2 on 3 minus 2, okay? And if we want these to be positive, we would move them about. So 3, 2 on 2, 2, which is the same as 3 on 2 squared. So do you see what happened here? We can take the fraction, which is 2 on 3, and we flip it over to be 3 on 2, and then we change the sign on the power. So minus 2 will become plus 2. You don't need to do this bit in the middle here. So if you want to make this positive, all you need to do is go 1,000 on 8 and make it 2/3. Okay, you want to try and finish that one yourself? I'll give you a couple of minutes. See what you can do with this one. See if you know what to do. I recommend change these numbers to be powers. Do that first. So I'll clean this section here. So I've got a bit of space. Eraser. Okay, so I recommend to change these numbers to be bases and powers. So whenever you see numbers, whether it's 8, 144, change these to be a number and a power. So do that first. And to the power 2/3. Okay, so do that first and then see what happens. I'll give you a minute to do that. So I'll give you time. If you want to work ahead, you can, but you can work along with me. And then if you can't do it, you just have to wait a few minutes or ask one of your friends there. So 1,000, write that to be something to something, some power, okay? So do that for a few minutes and see if you can get an answer out at the end. So no calculators. You can use the calculator to check at the end. So when you do your homework, you'll need to show your steps here. So what's 1,000 then? What to what power? Anyone? 1,000 is, that's an easy one, isn't it? 10 cube. Okay, let's write it here, 10 cube. I'll put it in. So 10 cube, which is 1,000. And what about 8? That would be 2 cubed. 2 cubed, like that. So what you just do here, remember these are multiplied. So if you had A, M, N, we multiply, remember? So here we've got 3 times 2/3. So you'll end up with 10 squared because this 3 will cancel this 3. So you get 10 squared here. And you do the same for this one. 3 times 2/3. The 3 will cancel the 3. You'll have a 2 left. So 2 squared. You could write that as 10 on 2 all squared now, because that's the same thing. And then that would be 5. That would be 10 on 2, which is 5. 5 squared, which is 25. So can you check with your calculator? That's right, should be correct. 25. All right, so on the next one, so let's scroll up a bit. I'll leave it there. So if you're copying that, you can write it down. So we'll do a couple more, then I'll give you like 5 minutes. Try these two here, I and J. Okay, try these two. Change to the same base. 4, 8, and 16. And this is base 2. So I recommend you change these to base 2 every part. I do that first. If you can do these, you can do your homework when it comes. Does anyone have an answer for question 1? Did anyone finish that? Answer, anyone? Or you're waiting for me? As long as you try yourself first. So this is meant to be like your classroom time for trying the questions.
I cannot, doctor. My brain does not work.
Yeah. So we'll change all of these to base 2. So you've got 2 to the 16, that's no problem. You've got 4, which is 2 squared, minus 8. See, now I'm making everything base 2. 8 is 2 cubed, and you got power 4 there. And 16 is 2 power 4, minus 2. So what do you do now? We can see, now we can simplify these brackets. So 216 is done. 2 times minus 8, minus 16. 3 times 4 is 12. And 4 times minus 2 is minus 8. So we're always trying to get these down to the same base, if possible. So now everything is base 2, so that's good. That means you can join them together. Now 16 minus 16, this would be 0. So when you're multiplying, remember you add all of the powers. So you'd have 16 plus negative 16 plus 12 plus negative 8, like that. So then we would just add those. So 16 minus 16 is 0. So that's gone. 12 minus 8 is 4. 2 power 4, which is 16 for the answer, okay? So that's the key. This is the main thing, is to change all of these powers and try to make them the same. And which we did, we got 2, 2, 2, 2. So then it's very easy to calculate the answer once you have that. Right, I'll leave it there if you're copying it. But with question J, I think there's an easier way. It looks a bit difficult because you've got a plus here, right? But I'm thinking 36 to the half. Well, let's change 16 to 6 squared. I'll make a square bracket here. Half plus 16, which is 2 to power 4. I did that because I know 4 1/4 will cancel. And there's a 1/3 there. Okay, you want to do a bit of work on that and see what happens. So you try and finish that one. And copy question I down as well. Can anyone get an answer for that yet? You see why I chose those powers? Because 2 1/2 will cancel to be 1. And 4 times 1/4 is 1. I could have made this 4 squared, but then I still need to simplify more. So 2 to power 4 is better. So 2 times 1/2, well, that's 6 power 1. And 4 times 1/4 is also 1. And that's 1/3. So 6 1 plus 2 1, well, that's 8 to 2/3. Now we can make the 8 2 cubed, power 2/3. I did that, so now I can cancel the 3. So that will cancel out the 3. And you'll end up with 2 squared, which is 4. Hold on, let me check 2/3. Oh, it's 1/3. Backtrack. 1/3. I'm thinking of something else. So 8 to 1/3. Okay, not 2/3. 8 is 2 cubed, 1/3. So if you write that down, rub it out. And 3 times a third is 1. So you get 2, not 4. 8 to 2/3 is 4. Okay, so that's 2 for that answer. That's how you get 2. So copy that down. Even if you don't understand it now, at least you have it on your tablet or your book, and then you have something to look at later. But I always try to think of an easy way to do these. You got plus, so it's do them separate first, and then add the number at the end for that one. We'll leave K, but it's because it's quite long. I can send you the solution later. But in that one, we would make everything base 5 here, base 5, base 2, base 4, and base 7. Try that if you want a bit of a challenge, and you get 1 on 16 for the answer. We won't spend time on that because I think it will take too long to go through. But you can try that yourself, and I can send you the answer later if you want to see the solution. That's K. Now, these ones, you're going to see these in your worksheet when you get it. Okay, so you got Y is 2 to power X. I want to get an expression of these in terms of Y. So what that means is, let's call this A, B, and C. I'll do the first one and see if you can do the others. So let's do A first. So we've got 8 to X plus 2. Now remember the rule AM times AN, that's times, is AM plus N. So it looks like we can use this here because we've got 8x plus 2. So rewrite that as 8x times 82. Okay, that's going to be 64, and this is 8x. But look what you require, 2x here. Here we have 8x. So I want to change this to 2, base 2 if I can. This is done. This is 64. Leave that alone. So we write 64 times 8x. So leave that alone. That's your coefficient in front. But 8x should be changed to be 2 power x. So 8 is 2 cubed. This is x. Okay, and so I'll write 64 again. So we're almost there, but this is 2 cubed. But the x is on the outside. I can swap these two because they're multiplied. It doesn't matter which is where. So I can bring the x on the inside. So 64 times 2x cubed. You see that? I just swapped the 3 and the x because our rule tells us that they're multiplied. So AM n can be written as AN M because they are multiplied. And the multiplication, it doesn't matter which goes first, does it? So now I've got y is 2x, and 2x is here, right? So I'm going to replace that with this y here. So I write y there instead of 2x, that's all. Looks a bit complicated, doesn't it? So 64 y cubed. That's your answer there in terms of y. Okay, that's part A. I'm going to leave you a bit of time to try that because I think these, you need to try and understand these today, these ones. And we got a couple here too. So we'll spend a bit of time on that. They're really just algebraic problems, just manipulating the indices. Okay, so you try B yourself for 5 minutes. and see what happens. But you've got 16x minus 1 now. So you're going to be doing a little bit different here. And what do we do with minus? Isn't that division? So I'll start you off. 16x divided by 16 power 1. Fix that. 16 power 1. Like that. And you could write that as 16x on 16. It's the same thing. So I'll give you some time. You try B and this one here, B and C. All right, do that for a while. If you got them done correctly, go down to the next question and do the same way. So I'll give you 5 minutes for that. Try that. So I'm thinking in this question here, we've got 16, which is 2 power 4, isn't it? X. 16 is okay, leave that alone. Now we have 4 bracket X, and as I did in the previous question, I would put the X on the inside. Bring the 4 on the outside, because that's exactly the same thing. That's 16. Now this here is going to be Y. I think I had an error in my answer key. Anyway, so it looks like this is going to become Y4 on 16. Did you get that answer? Anyone? Is that okay? Any problems there or not? I'll fix that one later on my answer key. Anyway, so the second one, or the third one, which was 4-2x. So let's write that here. Okay, doesn't look too bad. You got a 4 and we want 2 power x, right? Because we want in terms of y. So we need to see this 2 power x here somewhere. And we know 4 is 2 squared, 2x. So that's 2 power 4x, isn't it? 2 2s are 4. Now bring your x on the inside of the bracket. And then you see you're going to have y4 for that one. Any problems with that? So we're trying to get it in terms of y, which is 2 power x. So we need to see 2 power x. And when you get 2 power x, then you can write y in here for 2 power x. Okay, got that one? So if you're a bit slow, you're going to have to write quickly. All right, just scribble it down on your tablet or paper. But this one, question 3, is done the same way, except you may need to use 2. You've got x and z. So you need to try and change these to be 3x or 2x or both. Okay, so I'll leave you for 5 minutes for that one because that takes a little time. See if you can do these two here. This one's a bit harder. I'll let you know about this one. You got 6, which is not here, but we know 6 is 2 times 3, x minus 1. And we could write that as 2x minus 1 times 3x minus 1. I'll leave it there and you can do some more. And 9 here will be 3 squared. Like that. Okay, I'll write that and then you see if you can finish it. Those two there. Okay, 5 minutes for that one. So for question 3, Wonder if you got an answer. Let's see if you get it right. So here I would have 2. I will multiply out the powers here. 2x plus 2. Okay, you may have done it a different way. So this would be 2 times 3. I'm going to put my x on the inside. Put a 2 there and a 2 here. Okay, so I'm going to end up with okay, let's just see I'm doing everything right. Ah, 3 squared. Let's just fix that. So that would be times 3 squared because of this one here, not 2. Okay. So we'll go on. So in that case, 3 power x is y. So I'm going to put y into here. Y squared times 9. So you get 18 y squared for the answer for that one. Okay, something like that. So when you see these in your worksheet, go back and look at the video. I'll post a video of these so you can review how to do it. So 2x minus 1. Well, that's the same as 2x on 2 power 1, isn't it? And these are subtracted when you divide. And this is 3x on 3 minus 1, and put it under will be 3, 1. Okay, that's that one. So we already have our 2x and 3x. So, and 3x is y and 2x is z. So then we just substitute in here. So 2x is z. So z on 2 times y, which is 3x, 3 power x. So that's y on 3. And then you can multiply them. You'll get zy on 6 or yz on 6. So that's the answer for that one there. So the key is you need to change your questions to be in these terms, 2x, 3x, and then you can write in the y and z down at the end. And the same here, we had 3x here, which became y there, okay? So you'll see those again in the worksheet, not just yet, because you've got 2 worksheets to do already. 4 is quite hard, but now when you do these ones, you can do this yourself, but square inside first. So don't cancel like that. You'll end up with -2, which is not correct. You need to do your squaring first when you're trying to calculate a number. So that would actually be square root, -2 squared is 4. And then you would continue with this here. I'll let you think about that yourself. See if you can do that yourself, that one, without a calculator. The same with this one. We've got 15 minutes left. So I'm going to let you do this yourself. So what you would do here, if you were going to do this, you need to show that this here equals this. So you would need to simplify this. Have a go at these if you can, because I think there's a similar one in the worksheet that you'll get. So simplify this and it should look like this. Okay. The next topic is surge. So I'll talk about this. We won't do a lot today, but we can introduce this now. Okay, so here it says, surds are irrational numbers. Okay, if you remember what rational numbers are, rational numbers can be written as A on B, where both of these are integers, so whole numbers. So for example, 3 on 4 or 0.2 is okay because that would be 2 on 10. As long as you can write it like a fraction of two integers, those are rational numbers. So if you had root 4, well, root 4 is 2, and 2 is the same as 2 on 1, isn't it? So this is a rational number, rational. This one, root 4, because you can write it as 2, and 2 is the same as 2 on 1. And 2 and 1 are both integers. So this is okay. This is a rational number. But if you end up with like root 2, you can't do that. You're going to end up with root 2 on 1, and root 2 is a non-repeating decimal. So non-repeating decimal. Like pi. Pi is 3.14, but then you'll get lots of random digits after that. Okay, so there's no repeating number here. So pi is 3.14128, such and such like that. Okay, you can check on your calculator. But something like 9 on 11, you'll get a repeating decimal here. Who's got a calculator? Oh, here we go. So what's 9 on 11? So 9 divided by 11 is 0.81818181. So that's still okay. It's a decimal. And it will keep repeating. So this is a repeating decimal. So you could write that as 0.81 and put a bar across it, or 2 dots. So that's a repeating decimal. This is okay because it's a fraction. It's 9 on 11. So this is still rational. Okay, this is still a rational number, but it's a repeating decimal. But root 2, if you put in root 2 in your calculator, you'll get 1.414 213562, like that. So this won't repeat. It doesn't repeat at all. So root 2 is a surd. This is what we call surds. These are irrational numbers. They have a root sign and they have a number, but it's an irrational number. So for example, we can clear a bit of that. So as long as you're following, if you're having a problem understanding, I will repeat something. So if you had the numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we take roots of each one, some of these are rational, some are irrational. Some we can simplify too. So root 1, well, what's root 1? That's just 1, isn't it? So this is a rational number. Just write R. Root 2, well, that's getting a non-repeating decimal. So this is a surd. Root 3 is a surd, but root 4 is equal to 2. So that's rational. Root 5 is a surd. Root 6 is a surd. Root 7 is a surd. They all have non-repeating decimal. You can check your calculator. Root 8 is also a surd, but when we're doing this work in this section, we try to simplify. So root 8 can be written as 2 root 2. I'll show you how later. Root 9 is rational because root 9 equals 3. So that's a rational number. But these are surds because they have root signs. These are all surds. Root 10, that's a surd as well. Okay, so if you can take a root and get a whole number, it's not a surd. And this sign is called a radical sign. I'll just tell you that now. That's further down here somewhere. Okay, radical symbol, that's it there. So this symbol is called a radical. And these here are all radicals because they all have a a sign in them, a root sign. So you could have square root, root 7, cube root, this is still a radical, it's cube root 16, a fourth root 20. These are all radicals. Okay. There's some more examples here of surds. So the way to simplify these, we'll talk about this for 10 minutes and I'll do the introduction and we'll do some more work on the next period. So remember here, we've got, for example, a to the half times a to the half is a to 1. We remember we add these powers and we'll get a to the 1, which is a. And you can write it in this form because a to the half is the same as root a. And you've got root a here, which is a to the half, which is just what has been written over here. You can write them in radical form like this. And then we combine them under the root sign. And a squared is, because a times a is a squared, and a squared, the 2 will cancel the root sign to give a power 1. So whenever you have something like root 4 times root 4, you can combine them underneath the root sign as root 4 times 4. And 4 fours is 16. Root 16, which you know is 4, isn't it? Okay, you can go this way, or you can go this way, where you've got root 4, which is 2, and root 4, which is 2 as well, which is 4. Same answer. So you can go a couple of ways here. You can go down, or you can go across here. Depends on what is easiest. So for any root, it's getting a bit complicated here, isn't it? So let's look at some examples. We can talk about this later. So like I said, you could have something like root 8. Okay, so if I ask you to simplify, which I will later, simplify root 8. If you put root 8 in your calculator, put root 8 in, you should have calculator. How do you get 2 root 2, right? So this is be how you simplify, but without a calculator, we'll do this. We split up our number, root 8 as root 4 times root 2. Okay, so then that number can be broken here, go backwards to here. So root 4 times root 2. These can be split. And we know root 4 is 2 and root 2 is a surd, so leave it like root 2. Okay, we'll do a couple more. We'll do the cube root in a minute, but they're all done the same way. So for example, root 20. So what's root 20? You could do root 2 times root 10, but wouldn't it be better to do root 4 times root 5? Okay, because root 4 is 2 and root 5 is root 5, 2 root 5, okay? If I said, yeah, you could have, if you went the wrong way and you went root 10 times root 2, that's okay. But what's root 10? Root 10 is root 5 times root 2. 2 5s are 10, but you still have a root 2 here. Okay, so this number, root 10, is root 5 times root 2. When you break it apart using this up here. But then you have root 2 times root 2, which is root 4, which is 2. So that would give you 2 root 5 anyway. Okay, same, like that. But the cube root, I'll explain this one here. Let's just pan up. I'll leave it there so you can look at it later. So cube root 16. Well, how could you simplify that? What do we know about 16? 16 is 2 times 8. So we can do that. Well, 8 times 2. 2 times 8, same. Well, 16 is 2 times 8. And now we split it like we did here, but now we carry the cube root instead of the square root. Because these are all square root, aren't they? We just don't write that. But cube root, you will need to write. So you have cube root 8 times cube root 2. So just break this apart. You're allowed to do that. It's the same thing. But we know cube root 8 is 2. That's just come from your head. 2 times 2 times 2 is 8. So cube root 8 is 2. And then you're left with cube root 2, which is a third. So you would stop at that point. See, 2 times cube root 2. And there's nothing else can be simplified there. That's it. Okay. In another case, we talked about this already. If you've got square root 10 on square root 2, okay, we can combine these as is done here. So combine the root and then put the numbers underneath. Root 10 times root 10 on 2. Okay, that's better. And that would be cube root 5, isn't it? It could be square root. We didn't say, did we? It doesn't matter. Let's call it square root 5. So that's the answer. Another way you can do it, I'll do another way. So root 10, why did I write 2? Got a couple of minutes. So root 10 on root 2. Do you see another way we can do this? Anyone? Could we say root 2 times root 5 on the top? Because 2 5s are 10. So just treat these like numbers, but carry the root sign when you separate. And then you've got root 2 down here. So then you can see that this will cancel to give you root 5, which is what we got here. So there's a couple of ways to do these. And these work for any, even if you've got cube roots. So look at these two. So we've got root 18 on root 6. Combine under your root sign to give root 3. Doing it the long way, you would have root 6 times root 3, which is root 18, and root 6 here. And then again, like I cancelled before, you'll get root 3, same answer. You can do it that way. So look at the last one, because time's nearly up. And then we'll do some, we'll continue that maybe tomorrow, because we're doing okay with functions. So let's work on this, because I want to finish this section. So this one is cube root 32 on cube root 2. Same power, the same root, so this is good. And 32 on 32 gives 16. And then 16 is 2 times 8. And then I separate here to give cube root 8 times cube root 2 from here. And cube root 8 is 2 there. And that's your cube root 2 there. And that's finished. But these are easy to do by hand. Okay, you don't need calculator to do this stuff when you get practice. All right. Unfortunately, you didn't do this in grade 9. And you would have done that if you're using my old workbook. But because they changed to the school textbook, they don't have any of this topic, and I'm not sure why, because it's in Thai textbook. Anyway, so we'll stop there and we'll go into these examples on the next period.